We have a problem here that involves trigonometric integrals and substitution. It's a long problem, and one thing we want to remember when we encounter a problem like this is basically we know that tan squared x plus 1 equals secant squared x. How did I get this? Well, this is pretty simple to get. We know that cos squared x plus sine squared x equals 1. So we can divide both sides by cos squared x, right? You have cos squared x, and this goes into 1. This goes into tan squared x, so we have 1 plus tan squared x equals secant squared x. So we want to remember this identity and also the above identity. And now we want to substitute here. We want to substitute secant squared x into this formula. So how are we going to do that? Basically, we have to pick something here that's going to give us secant squared x. So what we're going to do is we're going to pick let x equals 2 secant x. 2 secant x is going to go into here. And basically, we're going to take the derivative of that, and that derivative is going to be 2 secant x tan x. I'm going to change the x's to thetas because we can't have the same values because we're subbing in something that doesn't even belong there. So I'm going to change the x's to theta. So this is going to be with respect to theta. And let's sub it into the equation. We should get square root of 4 secant squared theta minus 4 all over 2 secant theta to the power 6. 2 to the power 6 is 6. 2 to the power 6 is usually 64. So we can just simplify that, and the 4 can come out, so we can have 2 secant squared theta minus 1 under the square root sign of 2 to the power of 6, which is 64, secant 6 theta, right, d theta. We have to, this is dx, so we have to substitute in theta now, because we can't really take the integral. So what we'll do is, we'll take out this constant factor here, and this is the integral of secant squared minus 1. That's just this rearranged to get tan squared. Square root of that's just tan theta. And we know dx, so we're going to sub in for dx, times 2 secant theta tan theta d theta. So this is that, and this is going to be all over secant 6 theta. We can take out the 2, we can get a 4 here, 64. Secant theta goes with this goes to 5. So what do we have? We have tan squared theta times 1 over secant 5 theta, d theta. Okay, we now just converted this ugly looking integral into a trigonometric integral, but we're not done yet because we have to simplify this. And let's begin by just writing sine squared theta over cos squared theta times this is just cos squared theta, right? The inverse of secant is just cos, so it's going to be cos 5 theta. This is going to cancel out. This is going to turn into a 3 d theta. This is going to be 1 over. This is going to be 1 over 16. Okay, and so basically, now I think everyone's seen this before. You should have seen something like this before. When you have an odd power of cos and an even power of sine, what you want to do is make this an even power. So what we'll do is we'll take sine squared theta and make this cos squared theta, bring out a cos theta right here, and let's call that d theta. And let's put this 1 over 16. And remember from one of our identities that cos squared theta plus sine squared theta equals 1. And we can rearrange this for 1 minus sine squared theta equals cos squared theta. So we're going to sub this in here. We're going to get sine squared theta over 1 minus sine squared theta equal times cos theta d theta, 1 over 1/6. So now we're almost there. Now you know this part is just basically substitution, trig substitution, where what we're going to do is we're going to let u equals sine theta. We're going to take the derivative and we should get cos theta d theta. So now we can sub it in. We know this is cos theta d theta right here. We can rewrite this integral of u squared minus u to the 4 of d theta. From here on, it's basically simple integration, u substitution. So what you're going to do here is 1 over 16 times the integral of u to 2 is just u to 3 over 3 minus u to the 5 over 5 plus c. We're going to sub in u, which we said was sine theta. So 1 over 16 over sine cubed theta over 3 minus sine 5 theta over 5 plus c. Are we done? Sadly, we're not done yet because we have thetas. The original problem was in x's. So how are we going to transform this crazy stuff back into x's? Basically, we know that, remember we let x equals 2 secant theta up here. This was step number 1. When we did that, now we just solve for x. So we get x over 2 equals secant inverse of x over 2 equals theta. Now it's basically cos theta equals what? It's adjacent over hypotenuse. So this is just the opposite. This equals hypotenuse over adjacent. So we're going to draw a triangle here. Right? Draw a little right triangle. And then this is hypotenuse. So this has got to be the hypotenuse. This has got to be the adjacent. We know this would be x squared minus 4 using a squared plus b squared minus equals c squared. This squared x squared minus 4. Now we can sub in for sine theta. That's opposite, right, over hypotenuse. That's basically 1 over 16, right, of x squared minus 4, 3 to the 2, because that's what we're subbing in, all over x cubed. Obviously 3 here. Subtract that with x squared minus 4, 5 over 2, all over 5, right? 5x to the 5. This should be our final answer. We can simplify it a bit but so far this seems okay. And yeah, that's it.